Lesson number 95 is about graphs of nonlinear functions and recognizing shapes of various nonlinear functions. Now, nonlinear just means it's not a straight line. So linear is equal to a straight line. So whenever we look at these functions that are nonlinear, they're not going to be equal to a straight line. Let's graph this function first. We have f of x is equal to x squared plus 1. Now we graph these the same way we've graphed before. Remember, f of x is just the same thing as saying y is equal to x squared plus 1. So if we know y is equal to x squared plus 1, let's go ahead and make a table. We'll say x and we'll say y. And we could say y, or we could say f of x. Either way works. In this one, let's take 5 values. Let's say x is -2, -1, 0, 1, and 2. Okay, if x is -2, -2 squared, -2 times -2, -2 squared plus 1, -2 times -2, that's going to be +4, plus 1 is 5. If x is -1, we get -1 squared plus 1. -1 times -1 is 1, and 1 plus 1 is 2. If x is 0, well 0 squared plus 1 must equal 1. If x is 1, then we're going to get 1 squared plus 1. 1 times 1 is 1, plus 1 is 2. Oh, that's neat. This one, it has the same value as before. And then 2 squared. 2 squared is 4, plus 1 more is equal to 5. That one's also equal to this. Now let's graph and see what happens. -2 on the x is equal to 1, 2, 3, 4, 5 on the y. -1 on the x is equal to 2 on the y. And then we have 0 on the x is 1 on the y. 1 on the x is 2 on the y. And 2 goes with 5. 2 comma 5. What would happen if we had had 3? Let's look. If we had 3 squared plus 1, 3 squared is 9, plus 1 is 10. So we'd have 3 and 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 way up here. This one's also going to be the same. We've seen they're symmetrical on both sides of our graph. So we can now go ahead and plot this. And what we'll see is that any function like this is going to be a parabola. A parabola, it's like a smiley face. And a parabola can open up or it can open down. This type of function here, when we have x to the second power, our degree equals 2, x to the second is going to be called a quadratic function. And for any quadratic function, our degree always equals 2. And remember, the degree is your biggest exponent within the equation or the function. All right, let's look at another one. Here we have f of x equals x to the third power. So if we look at this one, let's make our x, y table, and this one's just going to be an x and an f of x. And let's start with -2, and we'll go up to +2. Okay, if x is -2, that means f of x is going to equal -2 to the third power, and that's going to be -8. If x is -1, -1 to the third power is going to be -1. 0 to the third power, that's a nice one. That equals 0. 1 to the third power, that equals 1. Oh, this one's a little bit different because here in our negatives, our answer stays negative. But when we come to our positives, our answer is positive. So they're the opposite, unlike our quadratic function. Then we have 2 to the third power. Well, 2 to the third power is equal to 8. And we've got our answer here. Now, if we look at this one, let's go ahead and graph. -2 on the x, that's going to go with -8. 1, 2, 3, 4, 5, 6, 7, and 8. -1 goes with -1. 0 goes with 0. 1 goes with 1. And we can see here in this problem, 2 goes with 8. 1, 2, 3, 4, 5, 6, 7, 8. And that's the shape of our graph. Let's go ahead and draw this one out. It's going to look something like this, with a nice smooth curve in the middle that hits all of our points and then comes right up to our last point. Now these ones, we don't use a straight edge because they're nonlinear, so graph them as best you can. If you need to make the lines a little bit thicker to pass through the points, just like I've done, you may do that. Or, if you wanted to show the points, you could always draw them in a different color. Now remember, this is a graph of a continuous line, so we need our arrowheads. Now this one is a cubic function. And it's a cubic function because we have a degree of 3. So anytime we have a function where our highest power or exponent is 3, we're always going to get a shape like this, where it goes up steeply, then a smooth curve, and then down steeply. Got a couple more to look at. Here we have a square root function. Let's say f of x and is equal to the square root of x. So we're going to have our table, x and f of x. And if we do this one, well, if we look at this one, x, let's make x -1. Square root of -1, well, we don't have a square root of -1, so there's no answer. Or we should say, there's no real answer. Let's make x 0. The square root of 0, well, that's a nice one. That's equal to 0. X is 1. The square root of 1, that equals 1. And then let's skip to something where we get a whole number answer. Let's say x is 4. Square root of 4 equals 2. If x is 9, the square root of 9 equals 3. So you can see it takes a lot of movement on the x-axis in order to get a little bit of movement on our f of x, or y-axis. So, x is 0, f of x is 0. X is 1, f of x is 1. X is 4, f of x is 2. X is 9, 5, 6, 7, 8, and 9. And our f of x is 3. So our graph is going to look something like this. A nice smooth curve headed out to the right. And if we made this negative, well, then we would reverse the direction that we'd be going in. We'd be underneath of our x-axis. And this one is, of course, a square root function. fxn means function, and a square root function will always give us that half of a parabola. Let's look at our last one. Our last one here is to graph the function. F of x equals the absolute value of x. Well, absolute value means a positive version of the number. So we've got x, and we've got f of x. So let's say x is -2 all the way to +2. Well, the absolute value of -2 equals +2. The absolute value of -1 equals +1. Absolute value of 0 is 0. Absolute value of 1 is 1. The absolute value of 2 is 2. So you can see whatever your number is on your x-axis, you're going to get the corresponding positive value on your f of x, or y-axis. So -2 and 2, -1 and 1, 0 and 0. 1 and 2, 1 and 1, 2 and 2, and you can imagine this just continuing. It's going to continue in a straight line, but it's going off in both directions. This one is making a nice V shape. And our V shape here will continue. I'm having a hard time drawing those straight lines diagonally, so let's back up. And we can use our tool for drawing straight lines diagonally. There's 1. There's 2. Remember, these are lines, so we need arrowheads. There's our first arrowhead and our second arrowhead. And this is a function, graph, that we'll get whenever we see something like this, where we're talking about absolute value. A V shape that can open upwards, like this one, or it could open downwards, if we were talking about negatives. Okay, that's a lot of information for today. We've got one example problem to look at that will help us identify these different types of nonlinear functions. So the question says, shown below are the shapes of graphs of the various functions. Match each of the functions below to the correct graph. So our first one is an upward opening V shape. Well, if it's a V shape, that must mean it must be absolute value. So absolute value, well, here's absolute value. So graph A is for absolute value because we have our absolute value bars around x minus 3. Graph B goes steeply up, then smooths out, and then steeply down. What is that? That must be a cubic function, B, and that goes with x to the third power because 3 is our highest degree, so that's cubic. C is a half parabola. It's opening upward, it's going steep, and then smoothing out as we go. So C, that's going to go with our square root function. So that goes with the one that we see that has a square root. And then D is a parabola. It's opening downward. Parabolas mean quadratic functions, degree 2. So here's D, because this one's degree 2. Our lesson practice will be on page 399. Make sure you've got your notes complete, and I'll see you during our next class.